Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Aziz bin Ramlan, and I will continue to explain to you about our project. Okay. Next I will explain to you about the problem statement for our project. The problem is the standard hand sanitizer is quite difficult to use, like this one, because it's require two hands to handle it. Sometimes it requires a quite force to get a liquid out from bottles. This may be a problem for some people, like older people. This project is to solve the problem and design the automatic hand sanitizer with built-in temperature sensor that helps people to get their hand to sanitize. The temperature sensor also keeps the body temperature always in check. This solution can help people to get through this COVID-19 pandemics much more easily. Okay, for the objective of this project focus on the automatic hand sanitizer dispenser with built-in temperature sensor as an open source platform for all people. There are three objectives for this project. Firstly, to construct a non-contact dispenser. Next, to design a low-cost body thermometer. And lastly, to design the user-friendly item. Okay, furthermore, I want to brief to you about the scope of the project. Okay, this project will be built using the Arduino Uno, which connect every component within it. As the name suggests, this project will features two crucial things, which are the automatic dispenser and the temperature sensor. It is assumed that this project could keep one in check of this contagious virus. Since the lockdown, every premise advised by the government to provide a temperature check and a hand sanitizer before they entering a place. This project undoubtedly also an excellent initiative to substitute standard hand sanitizer to the automatic version.
My name is Muhammad Ridwan bin Ismadi, and I'll be covering up on methodology and simulations of this project. So in order to read it up, this methodology, we are referring to the system development life cycle, which has three significant steps. The first one is planning. So in this step, we eventually collecting data and informations on how this project can be created. So after we studied, we find out that this project involves both software and hardware. So there are four main hardware that is needed for this project to run through smoothly. The first one is the ultrasonic sensor. Second one is the temperature sensor. And also the third one is mini DC submersible pump. The fourth one is the Arduino board, which connects both software and hardware, which it will be the brain in running this program. So for the software, we are using the Arduino IDE to create our coding, and also the Proteus software to design our schematic diagram. So next, let's move on to the next step, which is implementing. So this part required testing and troubleshooting. So before we test it, the schematic diagram is designed in the Proteus software. This is a schematic diagram of our project. Here is the ultrasonic sensor, the LM35, which is our temperature sensor, and the DC motor that represents our mini DC submersible pump. So before we continue to run the simulations, I would like to show you our project's coding. So this is our project's coding, which is created using the Arduino IDE software. So basically, this coding needs to be saved in a hex file and be transferred to the Arduino board on the Proteus software right here to for the simulation to run through well. So now let's run our simulation. So as you can see right here, the virtual terminal will be displaying both distance value and temperature value that is read by ultrasonic sensor, and LM35. So according to our project's coding, these two conditions of distance and temperature need to be met in order for the DC motor to be rotating well. So as you can see, the distance value is now more than 15 centimeter, which is why the motor is not rotating. Now I will bring down the distance. Now the distance is 10 centimeter and the motor is rotating well. So here is the other case where the temperature is not above 37 degrees Celsius and the motor is not rotating. After the simulation run through smoothly, we move on to the prototype. In terms of testing and troubleshooting, we make sure that all the connections are checked thoroughly to avoid any complications or short circuits that may cause some errors on the components. And last but not least, the final step is circuit analysis. This analysis is done to identify how many voltage is supported by each component. These need to be identified well to avoid any components from overheating and damage. So that's all from me. Thank you.
Okay, Assalamualaikum and a very good morning to our panel. So today I'm going to show you the tutorial on how are we going to use our automatic hand sanitizer. So as you can see, we have LED to indicate that our mini DC submersible pump is now active and are ready to use. We are using the LM35 because we want to use infrared temperature sensor, but the component is too expensive. So we use the LM35 to indicate the someone temperature if it is above 32 or below 32. We have mini DC submersible pump to pump out our water from the bottle. Then we have ultrasonic sensor to sense if someone put a hand to our hand sanitizer. So I'm going to show you first case about if someone's temperature is below than 32. So first we must to measure our temperature through LM35. As you can see from the serial monitor, the temperature is now 28.32. So when we put our hand, the mini DC submersible pump will pump out the water to our hand. So I'm putting my hand to the ultrasonic sensor and the pump is pumping out the water. Okay, on this part of the video, I'm going to show you the second case if someone's temperature is above 32. So now I have a lighter and I will light up the lighter near the LM35 until the temperature is above 32. As you can see now on the serial monitor, our temperature is 33.2. So now I'm going to put my hand to the ultrasonic sensor and to test out if the pump is pumping out the water or not. Alright. As you can see, when the temperature is above 32 degrees, then the mini DC submersible pump will never pump out the water through from the bottle.
Okay, for for the conclusion, the automatic hand sanitizer dispenser with built-in temperature sensor design was successfully implemented. Also, the objective of this project has been accomplished, where the project is capable of dispensing the sanitizer liquid and checking the body temperature. It is also designed to be user-friendly and easy to use. There is no doubt that this project will be beneficial in this COVID-19 pandemic. We also look for the improvement in the future that could be done for this project. The aim of this project is achieved.